Please subscribe, follow and like engineeringall.com.
The manufacturing of industrial electric motors. Understanding an electric works is an important thing, but industrial manufacturing of electric motors is another important, especially if you are the type that is scientifically inclined. A lot of discussions have been raised regarding electric motors and its manufacturing processes. Though it appears simple in its simplest types, the making of the giant electric motor used in the industrial machines has only few discussions made on it. Many enthusiasts wondered how the industrial electric motors have so much horsepower to carry heavy machines and equipment, including the modern increasing use of electric cars. The simple difference is the manufacturing methods. While the small and simple electric motors were made either manually or automatically with less sophisticated manufacturing techniques, the modern high-power counterparts were made from advanced automated manufacturing setup. According to the revelation made by the NIDE Group, top-known manufacturers of the modern electric motors, the current stator and armature of the modern industrial electric motors were made using sophisticated automated industrial method as well as quality materials. This practice has not only reduced the cost of production, reduction of production materials wastage, and making of electric motors with less defects records in mass production, rather it has helped to manufacture modern electric motors that can output high horsepower with low power input. The good impact of this can be seen in the modern electric cars. What made modern electric motors more powerful? The following are the things that made the modern electric motors more powerful. Use of suitable alloyed metals for the core. This has to do with the modern practice of using suitable alloy material for the making of the core of both the stator and the armature. The properties of the alloyed metal will help the coil to retain and magnify the induced magnetic flux generated in the coil. Use of quality copper wire. Modern wires manufacturing has been refined, that includes the copper wires. Having obtained the most likely suitable copper wire alloy for electric motors, the impact will not be like those made in the past. Quality bearings and lubrication system. No doubt, the bearings and lubrication systems have changed in the past few years. This means that its impacts are now showing in modern machines and engines, which include the modern electric motors. Good calculations of winding pattern. The calculations used previously in making the electric motors rarely altered, as majority seems to follow the known existing patterns. However, the modern manufacturing experts have deemed it necessary to venture into untried calculations in the making of the electric motors. Some of such trials resulted to discovering of ways the electric motor power can be improved through proper coil winding. In this post, we will be discussing about the industrial manufacturing of electric motors. The step-by-step approach involved. What is industrial electric motor? In case you are yet to understand what industrial electric motor is, it is a special type of electric motor with very high horsepower used to power most of the heavy machines such as washing machines, electric cars, industrial machines, and in reverse as alternators, electricity generators. A typical industrial electric motor could be said to be from 3 horsepower electric motors upwards. Components of electric motors. The components that make up an industrial electric motor is the armature. This comprises of the core and the wind copper wire wrapped around the core. It is the rotating part of the electric motor that has the central shaft fixed on it. The shaft of the armature establishes contact with the casing of the electric motor through properly sealed bearing arrangement enhanced with lubrications. It allows the shaft to rotate around the casing without friction. The stator. The stator is the part of the electric motor that is static. It implies that it does not rotate like the armature. It is usually fixed by the sides of the armature to provide the magnetic induction needed to rotate the stator. The contactors. They are sets of separated copper or brass metal fixed around the shaft outer part of the armature. It receives current directly from the power source and sends it to the coil to induce magnetic field. Some of the minor electric motor problems come from this spot, from losing contact with power supply to broken contactor unit, and lots more. The bearing and lubrication system. Typical electric motor has 2 ball bearings positioned at the 2 contact points of the armature shaft with the casing. The non-magnetic body casing, the outer body, casing, of electric motor is made with alloyed non-magnetic metal. This is to ensure it does not interfere with the magnetic flux inside the electric motor. How electric motor works. The working principle of electric motor surrounds the theory of Michael Faraday, a renowned scientist who discovered the relationship between magnets and electricity. The induced magnetic flux of a temporary magnetic field and current field flowing through the coil causes rotation of the armature. Common problems of electric motors. The common problems associated with industrial electric motors are slow speeding. This can happen as a result of low voltage supplied to the electric motor or faulty bearing if the slow speeding goes with strange sound. Stiff shaft. This is a situation where the shaft is not turning while the motor is humming when powered. The major causes of this problem are damaged bearing, internal obstruction of the armature rotation, and overload horsepower work unit being fixed on the electric motor shaft. Whispering sound. This is a common problem that can be noticed in any industrial electric motor that has been in use for a long time without proper lubrication. The problem of poor lubrication leads to bearing damage, which whispering sound can also be part of its signs. No power signal. This can be attributed to many factors, but the common causes could be contactors of armature problem, burned coil, or damaged capacitor. Manufacturing process of industrial electric motors. The following steps are used in the making of the industrial electric motors. Calculations. The first stage of making electric motor is to carry out calculations on the expected horsepower. Once the horsepower is known, the next is to calculate the type of wire, size of wire, and the number of turns for the stator and the armature. Once this is done properly, the next stage will come into play. Making of the core. The core is made up of magnetic metal sheets fixed together on the shaft. The design of the core varies according the type of the intended industrial electric motor. First, the full metal sheet is fed into shearing machine to cut into desired shape. The process is repeating until specific number of pieces obtained. Then brought together and forced into the shaft in a well-compacted arrangement. Choosing the right wire. The next step is to select the already calculated wire and position for the winding of the core. Core/coiling winding. Core winding is the process of rolling the copper wire around the designed parts of the core. This can be done manually or automatically using the coiling winding machine. Fixing of the contactors. Once the winding of the core is completed, the next stage is to start fixing the electric contact point, which can be known as contactors, on the shaft just above the coil. Then the fixing of carbon brushes that will be sending current to the armature will be done during the casing and assembling of the whole parts. Testing. Once everything has been completed, the newly made electric motor will be subjected to testing to ascertain if the calculated horsepower and performance meet up with the actual result obtained from it during testing.
For watching, please hit the red button to subscribe for more videos. Please follow and like engineeringall.com in all social media.